And welcome back, code friends and code family, to Cajun Coding. This is Saint Raz, and we are continuing our exploration of the programming language Python3, and we're doing that via the Mimu Play emulator and taking the course through the Solo Learn app. Both of those resources available free of charge. And we finished up our introduction to variables. Variables are something we're going to be using a lot of course, throughout. But we've been introduced to those. Now we're going to do in-place operators. In-place operators allow you to write code like x equals x plus 3, more concisely as x plus equals 3. The same thing is possible with other operators, such as minus, times, divide, and modulo as well. So what we've got here is x equals 2. So we're assigning 2 to x, then we print x, outputs 2. X plus equals 3, and then we print x. X is now 5. So it's the same thing as saying x equals x, the current value of x, plus 3. And that's useful when you're incrementing a variable for whatever purpose. You don't have to increment it just by 1. You can do it by whatever value you want. You can also decrease it, multiply, divide, modulo, whatever it is that you would need. So, and try yourself to play around with this code. I don't think we're going to need a whole lot of trial and error to demonstrate how that works. What is the output of this code? We're assigning 4 to x. X times equals 3, which is the same thing as x equals x times 3. The current value of x is 4. Multiply that by 3 and reassign that to x. 3 times 4 is 12. So this would be 1, 2. Just as a note here, this is 12. This is the integer 12, not the float 12. If it were a float, it would be 12.0. And my suspicion is that if we use just integers, if we use plus, minus, times, our result will be an integer. I suspect that if we use divide, then the result would be a float because we're using the division function. I shouldn't say function. Function means something different than in programming than just, I should say, operation, really. In-place operators. These operators can be used on types other than numbers as well, such as strings. So we have x, we're going to assign spam, so x is containing the string variable, x is the variable name. The contents of that variable is going to be a string, spam. Print x, spam. X plus equals eggs, print x, spam eggs. Now we say plus equal. This is actually using concatenation, not addition, which of course are similar but not exactly the same thing. But we can use concatenation as an in-place operator as well as addition. Many other languages have special operators such as plus plus as a shortcut for x plus equals 1. Python does not have these. So if you're playing around with Java, if you're familiar with Java, if we want to increment x by 1, we just x plus plus. Don't try that in Python. They're telling us that that's not a feature that it has. And what is the result of this code? X equals a, x times equals 3, print x. They didn't tell us how this would work, but from what we've learned from previous lessons, my suspicion is that this would be the answer. When we multiply a string by an integer, that string is concatenated a number of times equal to that integer. So, And it is. And we have exactly 333 comments. That has nothing to do with the lesson, completely irrelevant, but funny coincidence, no? Using an editor. So far, we've only used Python with the console. Entering and running one line of code at a time. Actual programs are created differently. Many lines of code are written in a file and then executed with the Python interpreter. In idle, this can be done creating a new file, entering some code, saving the file, and running it. This can be done either with the menus or with the keyboard shortcuts Control-N, Control-S, and F5. Each line of code in the file is interpreted as though you entered it, one line at a time at the console. And this is very similar to, and I think I've mentioned that before, this is very similar to Bash, Born Again Script, Born Again Shell, which is programming via an interactive command line interface. And I think that once I'm done with our Java exercises and Python exercises, an introduction to Bash and Linux might be the next step in the channel. But it's definitely something, don't have to wait around for that. Definitely go check it out. There's some resources out there that you can find, definitely worth becoming familiar with. Python source files have an extension of .py. Which lines are executed when a Python file is run? And actually every line is executed. They are executed sequentially, the first line first and then the one after that, and it's just as if you were using the command line interface, so it would be every line. I didn't really say a whole lot about the editor. Okay, how about the Module 1 quiz? And it looks like I leveled up there. What is the output of this code? Spam? Or we're going to put the string of the numeral 7 in there. Spam equals spam plus 0. Eggs equals int spam plus 3. So we've got 70, but 70 is a string, just those characters. We're going to call the integer function and change the string 70 into the integer number 70. Then we're going to add the integer 3. So we've got 73, the integer. So that's eggs. So eggs is 73. We're going to change that to a float, and then we're going to print. Now, when we print a float, even if there's nothing to the right of the decimal point, we're going to have 0.0 as a visual indicator that is the float type, float data type. And we got 73.0 right here. If you didn't understand some of the reasoning there, or I went too fast for you, go ahead and pause it, rewind, pause it, and step through the code line by line, and then see if your reasoning matches up with my narration. And if it doesn't, well, that's absolutely fine, but try it again. You know, repetition, great way to learn things, and you should understand why things behave as they do, not just accept blindly that they do. So, and what is the output of this code? Word equals input, enter a word, enter a word. Now this is going to kind of be the output here. It asks us enter a word, and then cheese is the input provided by the user. And then it says print word plus shop. The word, you see here, word equals input, enter a word. So word is the variable name we create, and then when it prompts us enter a word and we enter cheese, cheese is assigned as the value, which obviously is a string, to word. So when we print word, that word in this case is cheese, plus shop, So we get cheese shop. Now there is a little space here, so cheese and then space shop. Seems like it should have single quotes there, but I don't see single quotes. We have single quotes here, but there's no space. So I'm going to go with this. The output itself is cheese shop, though I think the display might actually put single quotes on it. And what is the output of this code? Variable x, we're going to store integer 5. Y equals x, which is 5, plus 3, so y will be 8. And then we're going to change the value of y. Okay, y is 8. We're going to make a string out of it, and then we're going to concatenate 2. So this contents of the inside these parentheses is going to be string 52, and then we're going to call the integer function, and we're going to change the string 52 into the integer 52, and we're going to assign that to y. Y had a value before, but forget that. That was then, this is now. Y is now integer 52. Then we're going to print y, which is the integer 52. Why? Because I gotta. And I'm wrong. What happened? See, 8. Oh, wait, it happened. What? It was 8? No, it's 8. I'm sorry. Y is 5 plus 3. That's 8. So this is an 8. The string is 82. Then we call integer and make it y 82. And then we print 82. Come on, try again. I got lost somewhere. There we go. That wasn't hard to do. That 5 stuck in my brain for some reason. And fill in the blanks to declare a variable, add 5 to it and print its value. Declare a variable, add 5 to it and print the value. So y equals 4, y plus equals 5, and then print the variable is x. Oh, you know what? I think we need, don't we need parentheses here? There we go. There we go. Well, that should do it. And what's the output of this code? X equals 3. A num is the name of another variable, so num equals 17. Print num modulo x, so 17 modulo x. 3 goes into 17 5 times with a remainder of 2. In modulo, we forget the division part and we just do the remainder. So it would be 2. 3 times 5 is 15, and then 2 more makes 17, so it'd be 2. And there we go for basic concepts. We're only about 13 minutes in, so we should be able to get into control structures. And look at the length of this. Hey, I thought, look this, we could do like 2 or 3 or 4 maybe videos. Looks like it's going to be longer than that. There's a lot more material here, which is of course good news because there's more to learn, and we're really going to hit the ground running, I think, when we get to the coding bat exercises. So moving on to control structures. Booleans and comparisons. Another type in Python is the Boolean type. There are 2 Boolean values, true and false. They can be created by comparing values, for instance by using the equal operator. And it looks like this operates the same as it does in C++, in Java, in JavaScript. There's a lot of languages where these kind of logical or arithmetic comparators are used. Use the same structure and the same symbols. So even if you go learn this and then just go immediately to a different language, it's just one of the things you don't have to learn over again. So that's good. So we're going to go ahead and declare a variable, my Boolean, and we're going to set it to true. There are 2 Boolean values, true and false. If we just print my Boolean, and then it'll give us the value we've got stored in that, true. Now this is a logical comparison or an arithmetic comparison. 2 equals 3. Now that's the expression. Is it true or false? If you make the statement 2 equals 3, well, 2 doesn't equal 3, so it's going to say that that statement is false. Hello equals hello. Well, now we're comparing strings, but those strings, as you can see, are absolutely identical. Java is, but Python, which is what we're discussing now, Python is case sensitive. So hello all caps or initial capitalization would not be the same as hello all lowercase. But hello and hello are the same, so true. And don't confuse assignment with comparison. A single equal sign is the assignment operator. We're not asking if my Boolean equals true. We're saying my Boolean is a variable and we are making it true. Whereas here we are making the statement that these are equal, but we're actually asking a question. This is our statement. Is it true or false? In this case it's false. In this case it's true. And moving along, what are the two Boolean values in Python? Truth and falsity. Seems a little philosophical and aren't exactly the terms we used. True and false and true and false. Aren't these the same? Nope. Look, these are capitalized up here. And remember, they were capitalized in the exercise there. So the Boolean values, true and false, should always be capitalized, I believe. And comparison. Another comparison operator, the not equal operator, which is the exclamation point and the equal sign, evaluates to true if the items being compared aren't equal, and false if they are. A lot of programmers have some abbreviations they use for some of these symbols. A lot of symbols are very, very familiar, but they have long names. Exclamation point and dollar sign are two of the biggest examples. If you have to say exclamation point or dollar sign every time you reference a character that literally only takes up one space on in the text, in the code, that's going to get old. A lot of programmers call this the bang. So bang equal, and then the dollar sign is usually called a bling. So bang equal. So one bang equal 1. Now when you're using it in comparison, a lot of times they'll just say not. So 1 not equal to 1. Well, 1 is equal to 1. So if you say 1's not equal to 1, then that statement is false. 11 is not equal to 7. These are strings, but they're not identical. And if they are not identical, then they would resolve as false. If you're saying they're not equal, then that statement is true. 2 is not equal to 10. Well, that is true. 2 is not equal to 10. So, and tap to try it yourself to play around with those. I don't think we need to do that. And we've got a guy in his underwear smoking on a beach. Okay, I don't think that'll get me demonetized, but apologies to any of the high school students, administrators for that. It's an ad. I couldn't do anything about it. What is the output of this code? 7 is not equal to 8. 7 equal to 8? It's no. Are we saying it's equal to 8? No. We're saying it's not equal to 8, which is correct. So the entire statement resolves to true. Python also has operators that determine whether one number, float, or integer is greater than or smaller than another. These operators are the greater sign and left sign respectively. 7 is greater than 5, that is true. 10 is less than 10, that is false. When we use these comparators in a comparison statement, we'll usually call those greater than or less than. If you're describing code to someone and you're using these symbols to enclose something, like with an HTML tag, sometimes they're called chevrons. Or this one that is has the point to the left, be called an opening chevron or left chevron, and this one pointing to the right, that would be a closing or a right chevron. But here it's greater than or less than. And if you have any trouble remembering which is which, in grade school they said just picture this as being like an alligator, and it's always going to be open towards the bigger side because the greedy gator wants to eat the greater quantity of food. And if that's stupid, I'm sorry, just forget it. But if it helps you remember, then whatever works, right? What's the output of this code? 7 is greater than 7.0. Logically, mathematically, this is not going to be true, because 7 expressed as an integer is not any greater than 7 expressed as a float. So I'm going to say that this is going to be false. There's no option for error, and I was wondering if maybe it would throw an error because these are two different data types. But since that's not an option, we'll just say false. Comparing different data types can sometimes get tricky in some languages. Haven't really encountered any instruction on that in this course. So the greater than or equal to and smaller than or equal to operators are greater than or equal to, less than and equal to. They're the same as the strict greater than and smaller than operators, except that they return true when comparing equal numbers. 7 is less than or equal to 8, that's true. 9 is greater than or equal to 9.0, that is also true. What is the output of this code? 8.7, so less than or equal to 8.70, and I would say that would be true. I don't see any reason for throwing an error there. And we're going on to another control structure, if statements. If statements, you can use an if statement to run code if a certain condition holds. If an expression evaluates to true, some statements are carried out, otherwise they are not carried out. An if statement looks like this. We have the keyword if, followed by an expression, followed by a colon, and then we have statements. Python uses indentation, white space at the beginning of a line, to delimit blocks of code. Other languages such as C use curly braces to accomplish this, but in Python, indentation is mandatory. Programs won't work without it. As you can see, the statements in the if should be indented. So here's our keyword if, that's the expression. Statement block of code should be aligned with the expression, so it's indented from the if, but it is not required to have any enclosures like the curly braces seen in C++ or Java. What part of an if statement should be indented? The statements within it, not the first line. It's kind of not sure whether they're talking about the line that includes the if conditional or the if keyword, or the first line of the block code. All of it? No, not all of it. Just the statements within it. The block of code to be executed. And we call it a code block because it might just be one line. It could just be a few characters, like the assignment of value to a variable or the change in a variable's value. But it could be a lot more than that. It could be pages of code. So we call it a code block. And if statements, here is an example of an if statement. If 10 is greater than 5, and then we indent here, print, and then we put out the string 10 greater than 5. And then down here we have print program ended. Now, if 10 is greater than 5, it prints 10 is greater than 5. If 10 is not greater than 5, well, we just don't do anything. Either way, it will print program ended. So the results, 10 greater than 5. Well, we didn't really did. Oh, 10 is greater than 5. Wow. Did I just say if 10 is not greater than 5? Actually, 10 is always going to be greater than 5. But my point was if the if statement does not result to true. 10 greater than 5, program ended. And we've got the underwear guy again. Alright. And he's using firearms now. Wow, the school board is going to love their students pointing this thing. Alright, what is the output of this code? Spam equals 7. If spam is greater than 5, print 5. And we do know that 7 is greater than 5, so we know that it will put out 5. If spam is greater than 8, print 8. Now it's possible for a variable to be greater than 5 and greater than 8, but since spam in this case is 7, it is not. So it will print out 5. To perform more complex checks, if statements can be nested, one inside the other. This means that the inner if statement is the statement part of the outer one. This is one way to see whether multiple conditions are satisfied. For example, we assign 12 to the variable num. If num is greater than 5, it is. Print bigger than 5. Now we have another if statement if num is less than or equal to 47. Notice that this if statement, the if conditional, is aligned with this code block, the print. So that means this if statement is nested inside this if statement. This will only run if this if statement resolves to true. If this statement is false, the interpreter is never going to get to this statement. Now, it's 12 is bigger than 5. It is less than 47. So the output would be bigger than 5. And then it would also print between 5 and 47, like so. What is the output of this code? Num equals 7. If num is greater than 3, which it is, print 3. If num is less than 5, 7's not less than 5, so it's not going to print 5. If num equal to 7, print 7. And now the answer to this one is going to be 3. And if you're confused about why is it not 3, 7, it's because it never reaches this. When it reaches this line, num is not less than 5, then it is going to kind of skip down and look for something that's indented here. It's not going to get to this. It's never going to read it because this if statement is nested inside the code block that's executed only if this if statement resolves to true. Let's see, let's not defeat cybercrime yet. Some people really don't like all the ads and stuff, but if I have to look at an ad for 2 seconds, so I don't have to pay for something, that's fine with me. And that is kind of part of the theme of my channel, is to provide and point people in the direction of resources that have no financial cost. So okay, and else statements. An else statement follows an if statement and contains code that is called when the if statement evaluates to false. As with if statements, the code inside the block should be indented. If, x is going to equal 4, we're assigning 4 to x. If x is equal to 5, print yes. Else, and you notice that the else keyword is aligned horizontally with the if keyword. Else, print no. and notice that this is indented from the else. This code block runs if the else is I don't know, because else doesn't really do else isn't really a conditional. It's not making a comparison. But if resolves to false, then the else block executes. We just use the else keyword to indicate where that code block is going to be located. So if x equal, we're going to assign 4 to x. If x equals 5, which it does not, this does not execute. Else print no, and there it is. It prints no. And this if-else structure is the same for every language I've ever encountered. It's going to be the same basically in JavaScript. It's the same in C++. It's the same in Java. And what they're showing me here is very familiar. There are just few minor modifications with languages. There are no symbols that enclose them in Python. And indentation, which doesn't matter in other languages except for style or readability, actually affects the way the code behaves in Python. So be careful with your indentation. What is the result of this code? If 1 plus 1 equals 2, well, that's true, so it's going to execute this. If 2 times 2 equals 8, well, that's not true, so this doesn't execute. There is an else, so we do execute this code, which instructs the interpreter to display else, so it outputs else. You can chain if and else statements to determine which option in a series of possibilities is true. Let me see, for example, if num equals 5, print number is 5. Else, if num equals 11, print number is 11. Else, if num equals 7, and so on. Else, we checked all of these, so we print number isn't 5, 11, or 7. Now remember these nested if statements? The nested if statements that are enclosed in the else branch of the if-else structure. If any of these ifs come back as true, it's going to display something. It's not going to execute anything in the else. It's a fork in the road. You can do one or the other, but you're not going to do both. In this case, the else block of code presents you another fork in the road. So, and the number is 7, as we can see. Fill in the blanks to compare the variables and output the corresponding text. We're going to assign 10 to x, 20 to y. Now we want this, see output corresponding. So what do you mean output the corresponding text? So x if statement. So this is going to be if x is greater than y, print if statement, and then we have else here. Else is else gonna have a, I think else has a colon. Why is there a space here? Am I missing something? Yeah, I'm missing something. What do we put there? Click the hint. They do have a colon there. I missed the colon there. I'm not going to confuse you with telling you what symbols you would use in another language, but there's all kinds of symbols that enclose and stuff like that. In Python, we just use the colon after the conditional, which is your arithmetic comparison or your comparison of strings, whatever it is you're looking at. You do the comparison, and then you use a colon to end the conditional part of the if, And then the next line, be sure you indent it, is the code to be executed there. And then the else is optional. If you don't need anything to happen, if the if is false, you don't need that. If you do want something to happen, then be sure you put the else and the code block if the else is used. elif, I guess that's how that's pronounced, elif. The elif, short for else if statement, is a shortcut to use when chaining if and else statements. A series of elif statements can have a final else block, which is called if none of the if or elif statement expressions is true. For example, num equals 7. If num equals 5, print number is 5. elif num equals 11, print number is 11. elif num equals 7, print number is 7. Else print number isn't 5, 11, or 7. Now notice in these multiple elifs, they're on the same horizontal alignment there. So these are not nested, they're chained, which is an important distinction. Equivalents to the elif statements in other programming languages: else if with no space, or else elsif, which I would assume is still pronounced else if. I'm kind of familiar with these two. I don't know what language this is from. I've not encountered that one. A shorter option for else if is elif. Okay, and Boolean Logic. I think we've got time to get through this section here. Boolean Logic is used to make more complicated conditions for if statements that rely on more than one condition. Python's Boolean operators are and, or, and not. The AND operator takes two arguments and evaluates as true if and only if both of its arguments are true. Otherwise, it evaluates to false. So we're going to print out 1 equals 1 and 2 equals 2. Well, 1 equals 1 is true, 2 equals 2 is true. So since both of them are true, it's true. 1 equals 1 and 2 equals 3. 1 does equal to 1, but 2 does not equal to 3. We're using AND, so if either of them are false, then the whole thing is false. 1 is not equal to 1, and 2 is equal to 2. Well, 1 is equal to 1, so this is false. The whole expression then is false. 2 is less than 1, and 3 is greater than 6. Neither one of those are true, so the whole thing is false. Python uses the words and, or, and not. Boolean operators in other languages often use symbols like the and symbol. These are called pipes. Usually it's the shift, it's the key just above the enter key, and it's usually uppercase, so it's shifted. Those are pipes. And then the bang operator or not. What is the result of this code if 1 equals 1 and 2 plus 2 is greater than 3? Both of those are true, so it'd print true. Else is only going to be executed if this statement resolves to false. So in this case, it's not going to execute. So it's just going to be true. Boolean OR. The OR operator also takes two arguments. It evaluates to true if either of the arguments are true, and false if both arguments are false. And this is the inclusive OR. 1 equals 1 or 2 equals 2. Both of those are true. 1 equals 1 or 2 equals 3. False here, but this one's true, and it will resolve to true if either is true. 1 is not equal to 1, that's false, or 2 is equal to 2. That's true. Whole thing's true then. 2 is less than 1 or 3 is greater than 6. Neither of those is true, so it comes back false. Fill in the blanks to print welcome. We're going to set age to 15. We're going to set money to 500. If age is greater than 18, it's not. Money is greater than 100. Money is 500. Money is greater than 100. So we're going to use OR. The reason we use OR is if we used AND, well, the first part's false, so the whole thing's false if we use AND. So we use OR. And what are we going to do? We're going to print welcome. And there's the Boolean NOT. Unlike other operators we've seen so far, NOT only takes one argument and inverts it. The result of not true is false, and not false is true. So 1 equals 1, not. 1 is equal to 1. So if we flip, that's true. So if we flip it, it becomes false. 1 is greater than 7. 1 is not greater than 7. That's false. If we use not and flip it, then it becomes true. And you can chain multiple conditional statements in an if statement using Boolean operators. What is the result of this code? If not true, print 1. Elif not 1 plus 1 equals 3, print 2, else print 3. Okay, so if not true. If a statement evolves to true, then the block below the if conditional check is going to execute. So it's valid to put a statement if true, not a conditional, just the word true. That the code block below that statement is always going to print, because we're basically telling it to execute the following code block. And it seems kind of silly to do, but you know, if true, print it. And since the you could also use the number 1, if 1, and then because 1 is considered equivalent to the Boolean value true. So it's always going to print. If you just say if true, whatever you put in the code block below that is going to execute. Now we're using the not, so if not true, then this is not going to print. Okay, so it falls down to this statement. Okay, elif not 1 plus 1 equals 3. 1 plus 1 is 2, it's not 3. So this is false, but then we're going to flip that value because we're using not here. So this resolves to false, then we flip that to true. So this whole line, oops, this scrolls, I was trying to highlight it, but oh well. So this whole line resolves to true, which means that it's going to execute this and print 2. This else is aligned with this elif. It's not nested. So when this resolves to true, this is going to be printed. It's not going to reach this line of code. So it's going to be 2. And just in case you're wondering, this is not an integer. This is the string consisting of the numeral 2, not the integer. That's not really relevant right now for this exercise, but do keep an eye on data types. Okay, and it looks like we're about 45 minutes in almost, so we're going to go ahead and wrap this up and continue on in the next video with operator precedence and go from there. Alright, thanks so much for tuning in, guys. Appreciate it as always. Like, subscribe, recommend the channel to your friends, colleagues, acquaintances, whatever. And if there are any questions, concerns, suggestions, or requests, go ahead and hit me up on the channel. Thanks again, guys. Talk to you next time. Bye-bye.